Alright, so first up in here, we have the newest Netgate pfSense release. That is 2.4.5. And it was released on March 26th of 2020. So this newest release of pfSense is based off of FreeBSD 11.3 stable. So it's been around 10 months between releases, but to be honest, I really feel in that time Netgate really refines their product, to be honest. Seems like a long time for a firewall distribution, for a security appliance, but on the other end of that, they do need to have a period where everyone runs the same code, where the features get stabilized, and where you have no unpredictability with how the software is going to operate for you, especially security software. And as always, they would have released a patch if anything came up that was, a security issue. So, as far as updating, if you're on the 2.4.x branch right now, the instructions are pretty much a normal day at the office. You want to log into your pfSense, you want to navigate to the System tab, then go to the Update tab under that. Then you want to set branch to the latest stable version, which it will be at this time, 2.4.0. And you want to confirm. You want to click Confirm, and that starts the upgrade process. So if for some reason, let's say, you can only get access to the console of the device. Maybe you have a server that has console cables connected into it, a console access server, or you just have SSH access for some reason. The instructions for doing it from the console, you just want to log in there, and once you do that, type option 13. And then once you do that, it will start the upgrade process. So I'm sorry, option 13, or you can open the shell with option 8. My apologies. And you can run pfSense-upgrade. And then that will upgrade the system in an alternative way. All right, and again, to check out details about that, either go to pfSense.org or netgate.com. Okay, switching gears here. So we can have a little bit more of a broad brush discussion. We're going to talk about what an IP address is. Just real quick and very easy to understand terms. So the easiest way I can think to explain an IP address is the Postal Service. When you write a letter, send a form, whatever, you have a source on that letter and you have a destination. So where it came from and where it's going to. Well, an IP address is similar to how we'd put on our home address on an envelope. It identifies where it came from. So that's what an IP address is for a source IP address in a packet. That identifies where it came from, and then the destination IP address in the packet or on an envelope is where it's going to. And the postal workers and everything are moving that letter closer to where it needs to go. And they know that because they know how mail should flow in different counties and cities and states and things like that to get the mail where it needs to go. You actually have a lot of similarities to computer networks because they have redundant paths between the states for getting the letter there, redundant ways to carry that letter. Similarly, how routers have routing protocols and load balancing and other things like that to always make sure packets can get around computer networks. All right, next up here, we have an IPfire release. So this is IPfire 2.25. And this is Core Update 142, and it was released March 18th of 2020. So some specifics about this one here. This update does bring a new kernel, and that kernel is based on Linux 4.14.173. So we're on the 4.x branch of Linux at this point in IPfire. Now, they also have Suricata as their their IPS system, and they went and updated that to 5.0.2. And of course, it brings, performance improvements, and I would assume to some degree security improvements, because, if it's processing packets, that's obviously where you want more security. You don't want something where the packet can do something malicious or something it shouldn't do in the system, cause a denial of service attack, something like that. But if you do want to download that and check that out, run it in a VM or anything, that is IPfire.org. Again, IPfire.org. And in case you missed it the first time around, the ones for pfSense are pfSense.org and netgate.com. All right, our last one here on the list of firewall network distributions is Untangle. So Untangle has released their next generation firewall product, 15.0. And I couldn't find a month on this one. It wasn't sometime in 2020, I know that. But in this release, they have a new threat prevention application. Just get my notes up here. So the threat prevention, if I could talk. So the threat prevention is a new application in Untangle, and what this does is it blocks traffic, but it does it based on the URL, maybe of a GET request to a web server going through the network, or that IP address, the source and destination IPs we just talked about. It has IP address malicious reputation, so based on the destination, if that IP has been known to be malicious, it can block traffic that way as well. So if it does block a web session, all other non-web sessions will be dropped. So meaning that if you do connect to something malicious, any command and control channel that may have opened that's not necessarily a web connection would directly be dropped by Untangle in the stateful firewall. Okay, one downside, if you look at it that way, it is part of the complete subscription. So, you do have to pay them for that service, but I mean, in a company, it's worth it, because if you have a security breach, that's going to cost you more a lot of the time than the fee to keep your security software up to date, especially a firewall. Okay, and again, they've upgraded the kernel to this, in this case, 4.9.0-11. So because it's an upgraded kernel, you will have to reboot at this point after installing this. So do be aware of that. And do make sure the hardware is compatible. A few miscellaneous things they've done specific to this product is they have a network interface mark preservation. And this is meant to improve interoperability with other advanced routing protocols. So I believe it's actually inside of the software itself. It's not like a TOS bit or a COS bit for, anything marking like that. It's actually marking the packet inside of their software itself. Because remember, Untangle does a lot more than a normal router, and when they talk about marking, that may very well be inside of their own software stack that's processing the packets at layer 7 to keep track of certain things and tell applications to operate on the packet before getting it back down the stack and sending it out there. Okay. They fixed an issue here with Google Drive. They fixed that. And their reports app now properly escapes HTML and JavaScript to prevent injection of out-of-band cross-site scripting. So it's very important, again, because that protects the web admin interface. All right. So the last few things we're going to talk about, I'm kind of going to group them into one. We're going to talk about a switch in a network. So I specifically mean an Ethernet switch. With Ethernet switches, what they do is they facilitate communication between computers that are in the same LAN. So because of this, those computers will be also in the same IP network. So they're gonna, if you look and find your IP address in your computer right now, switches are meant to only let you communicate with a computer in that same address space. So the numbers have to match up. In most home networks, everything but the last section of that address will match up. And if that happens, that communication is going to take place at layer 2 with the frames and the MAC addresses that go with the frames. The MAC addresses are very similar, but instead of identifying an entire network like IP addresses can, and a computer in that network, MAC addresses identify the network card of the computer directly. You need both to have a communication occur between computers on a network, but MAC addresses are local and they stay within your network. IP addresses are routed, and they go out of the network. Not always, but most times. So the basic of how a switch operates: if a frame comes in that's sent from a computer, it looks at the source MAC address of that frame and it puts it in its CAM table. And CAM stands for Content Addressable Memory. And the CAM table there just stores what MAC address is on what port. Okay? So it uses that, but when it needs to figure out what computer it goes to, it actually looks at the destination address, the destination MAC address, and floods it out, all ports except the one it came into. So it floods it all out, all the ports, and then when that PC that it was meant for responds, it knows that source address. So then it can more quickly just send it to that PC directly when another communication for those two come through. So it learns the source, finds out what port it is on, and then it uses that destination MAC address in its CAM table to send it out the right port. Okay, along with that, how we talked about the IP networks, what a router is. So, routers are very similar to switches, to be honest, at least in the way that they process packets using addresses. They have a routing table, and when a packet comes in, it looks at the destination address. Now, when you configure a router, though, when you put the IPs on the interfaces, it makes routing table entries. And it already knows where those sources should be coming from. So it has that, and then when the packet comes in, it looks at that packet's destination address, and that enables it then to compare that address there at the destination with its routing table. And again, that table is directions of what interface it should go out of, etc. So then it sends it out to the correct interface after seeing that. And when it comes back through, it does the same thing, but it just would send it back to your LAN at that point. So But that's the basic idea of routers. So, a firewall. A firewall can take, some of them can operate at layer 2 and filter on MAC addresses. A lot of them operate, though, at layer 3 and 4. And they can stop packets from passing, depending on what the source address is or the destination address is, so where the flow is and where it's going. But they can also filter on port number and protocol. So not only can you restrict who can receive packets through the network, not only who can send them and who they can send them to, but by controlling the port numbers, you control what services on those IP addresses they can access as well. And of course, on the internet, who can access you as well, because it would block packets that aren't allowed. And most firewalls today, once they allow a packet, they create state. So basically, they note it down and remember that. So when it comes back through, it won't drop it, that communication. So if your computer connects to google.com, the state your Wi-Fi router remembers it, so it will actually let the reply packets from google.com come back through. Because if we didn't have the state, that would actually be a state mismatch, and it would just drop the packet because it wouldn't remember. All right. So how to access your Wi-Fi router's admin page is our last topic of discussion for today. So it should be straightforward now that we've talked about IP addresses, MAC addresses, firewalls, and all that. But how you access it is the easiest way is to look at the bottom of the Wi-Fi router, if it's a Netgear, Linksys, Belkin, whatever. One thing, I don't know if Belkin makes Wi-Fi routers right now, as of 2020. I think since they acquired Linksys, I think they just sell Linksys, but don't quote me on that. Last time I looked, though, I couldn't find any Belkin routers on their site. One, but it was almost sold out. But anyway, though, the IP addresses are usually like 192.168.1.1. But once you type that into your browser's search bar up there, once you type that in and hit enter, it will go ahead and load up the administration page for your Wi-Fi router. But after that, you just put in the username and password there. And you usually have a default one. You usually have admin password or admin or something like that. But nowadays, they're actually having randomized ones that are still default enough for that device, but random enough so not everyone would know it. But the easiest thing to do is look at the bottom of the router. Once you get in here, you can change IPs usually on them. You can edit very, very basic firewall, basically turn it on or off. You can do NAT-related operations. That's network address translation. It basically allows all your PCs on your LAN to share one address given to you by your ISP. You can do all those things, and if you research more, like we said about the firewall distributions, you can put things on your Wi-Fi routers like OpenWRT or dd-wrt, and that actually gives you access to more of the advanced features of the operating system on that device. Well, it's its own operating system, but basically the web interface gives you less control over the operating system in any of these products, to be honest, because they're only letting you access features that the interface is designed to have in them. Whereas the operating system underneath, like if you use these firewall distributions or you use something like BSD or just Linux and build your own firewall, you have full access to the operating system underneath. So you have free reign to customize it however you want. For older Netgears, if you still have one, it was 10.0.0.1, by the way, for the IP address. I really hope you enjoyed this different format with all that. I'm Tyler with T-Tech, and this was a episode of T-Tech Nibbles. Again, episode 0001 for March 31st, 2020. Hope you enjoyed it, and thank you for listening, and have a very nice day.